All right, welcome back. You've already learned how to use the contradiction symbol in contradiction intro and contradiction elim. Now that's the last thing that we need in order to understand how proof by contradiction or reductio ad absurdum works. That's just the informal name of the proof method that we're going to call negation intro. So in this video, we're going to talk about the informal version of proof by contradiction, or what I'll just call reductio for short. So your first job is to see if you understand how reductio works and use it to prove this argument is valid. So pause your videos now and give me a proof that this argument is valid and use the reductio method. Okay, you should have paused your videos and given me the proof. You actually need to write down this proof in order to get practice doing this so that you'll internalize and really remember these things. Now, if you use the reductio method, you need to assume something temporarily. Let's see if you can answer this question. Is one of these things the thing you assumed for your reductio assumption? So pause your videos and tell me whether you assumed A, B, C, or D here. Okay, last chance is to pause your videos. The thing you should have assumed is D. When my conclusion is this, P is not the tallest person in the room, to do a reductio, you always assume the opposite of your conclusion. So if the conclusion says she's not the tallest person, I need to assume she is the tallest person. So D is the only correct answer. If you answered A, B, or C, something was wrong in your proof and it's not going to work properly. Now let's see what the full proof would have looked like. This is what you do when you do a reductio. Let's assume for reductio that Pia is the tallest person. Let's assume the opposite of what we're trying to show. And what we're going to do with reductio is to prove that that can't possibly be the case. It's impossible for Pia to be the tallest person. If it's impossible for her to be the tallest person, then we know that she isn't the tallest person, has to follow validly from those premises. Now, so there's our temporary assumption. Pia is the tallest person. Since Pia knows Quinn and Raquel, so here I'm just restating premise number one, that means that the tallest person in the room knows Quinn. After all, Pia is the tallest person in the room, and she knows Quinn, so the tallest person has to know Quinn. But look at premise number two. That directly contradicts what premise number two says. So we know if on that reductio assumption that a contradiction results. We know that we hit an impossibility. That tells us the reductio method then allows us to conclude what we want, that Pia is not the tallest person in the room. So here we're just finally restating our ultimate conclusion. And that concludes our informal proof. Now, if that wasn't familiar, if that didn't make sense, let's talk about exactly how the reductio arguments work and why they're valid. The reductio principle, this is my explanation for why this method of argumentation works. If you understand the reductio principle, then these arguments, proof by contradiction or proof by reductio, might make more intuitive sense. Here's what the reductio principle says. So this is the thing I want you to understand. Let's say we have three things, A, B, and C, and they all entail a contradiction. If that's the case, then two of them alone, like A and B, have to entail not C. And any two of them entail the other. So B and C would entail not A, and A and C would entail not B. If three things entail a contradiction, then any two of them would entail the negation of the other one. So you might be wondering, why am I focusing on A and B and C is the one that gets negated? Because you're going to be using this method when you have an argument which gives you a conclusion, and you're going to be concerned about negating the conclusion just because of what the premises are. But that doesn't mean that there aren't other valid arguments out there, and you could have taken two of the other ones as premises and one of the other as the negation of the other one as the conclusion. Okay, let's talk about this thing. So what I want you to do is understand this principle. If A, B, and C entail a contradiction, then A and B entail the negation of C. If you understand that, then the reductio method will make a lot more sense. Here's my justification. Here's my explanation for this thing. First, let's do it in two steps. Let's say that A, B, and C do entail a contradiction. Now remember the contradiction principle. Anything that entails a contradiction has to be a contradictory set, because only a contradictory set can entail a contradiction. So if we know A, B, and C entail a contradiction, then we know A, B, and C are a contradictory set. Now, look at the next step. Let's say they are a contradictory set. If that's the case, then A and B must entail the negation of C. Now, why is that? Let me go through an explanation about why that has to be the case. Because first consider this part. Let's say A, B, and C do form a contradictory set. Now imagine that A and B are true. Any two of them, let's say two of them are true, like A and B. Then C, the other one, has to be false. Because if it's a contradictory set and two of them are true, that means they can't all simultaneously be true. So whenever A and B are true, C must be false. If C is false, then the negation of C is true. So that means that if A and B are true, the negation of C must be true, which is just our definition of validity. This thing says anytime A and B are true, then the negation of C is true too. This is our definition of validity. So really, if you can follow through this explanation, it's sort of a zigzaggy explanation, follow all of these arrows, the reductio principle will ultimately, hopefully make sense. That is, let's say we have three things that entail a contradiction, then two of them must entail the negation of the other. If that makes sense, then let me show you how proof by contradiction works. Like, let's say I have this argument where I'm assuming A and B. I'm giving you an argument with A and B as premises and the negation of C is the conclusion. You see, this is why we care about assuming A and B are true and negating C, because I've given you the argument that looks like this. Now, the proof by reductio method works by first, I'm going to assume the negation of C. This is step one. You have to make a temporary assumption with this method. The next thing I want to do, if you want to use this method, is show that a contradiction follows from my temporary assumption plus my original premises. If I can do that, then I know that A, B, and C together entail a contradiction. And because of the reductio principle we just talked about, that means A and B must entail the negation of C. That means this is valid, which is what we're trying to prove. We're trying to prove that this argument is valid. So that method, the validity of that method really follows from the reductio principle. If you understand that principle, then the method will make a little more work. Go back to this example if it's still slightly confusing for you. This example that we looked at before is actually an illustration of this method. You see, my conclusion here, take sentence C to be Pia is the tallest person in the room. My conclusion, remember, is the negation of C. So here is my conclusion. And remember our temporary assumption, our reductio assumption was to assume C, that Pia is the tallest person. And we showed that a contradiction follows, that that's impossible. That's why we know that the negation of C follows from those two premises. Okay, that is an explanation. In this video, we're talking about the informal proof method called proof by contradiction or reductio. All right, thanks.